Hi all, in this video we are going to see about Ipsec IKE Phase 1. Let's get into the video. First of all, what is an Ipsec? Ipsec is nothing but it's just a framework that helps you to protect a IP layer, that is a IP package. What it can do by protecting means it can give some of the functionalities as confidentiality, integrity, authentication and anti-replay. So what each of these terms means. First of all, gets into the confidentiality. Confidentiality means it helps you to protect your data. That is, it helps you to encrypt the data which when you are sending your data in one format, let's consider you are sending it in the format of X, Y and Z. And while it is being leaving the concerned router, it will be in any other format as dollar. It will be in some sort of alphanumerical orders, so that it cannot be directly seen by the third parties. So that's what a confidentiality gives you. It helps you to encrypt the data. Only the sender and the receiver can decrypt and get the information. That's what a confidentiality is all about. Next is integrity. What does the integrity means? When the location A, there is a router A and router B, tries to communicate, the data that is sent between them should not be changed. Suppose a third party hacker tries to capture the packet and he just changes some of the information. Let's consider you are sending information of A, B and C, and the B should have to receive the same information of A, B and C. If the third party tries to capture and if he tries to alter the information as you just change it to A, B, C, D, it is additional information. So if we get the packet with A, B, C, D, it's not said to be as a correct information. It's some sort of unreliable information. So in order to overcome that, the integrity is being placed in the IP packet. So it can be done by using a hashing algorithms. Next is about authentication. Authentication is nothing but you just want to make sure to whom you are speaking is the right person to give the information. Suppose if a router A and router B wants to communicate and router A needs to send a packet to router B, he just want to confirm is he the correct router B to send the information, or it might be any other routers C or D. We just want to make sure to whom we are speaking is the correct person. That's what authentication do. Next is about anti-replay. Anti-replay helps you avoid duplicate packets. Suppose if a router A and router B transmits a packet between each other. Suppose the third party hacker tries to get the packet and he can't do anything, and then what he does is it tries to duplicate or sends a frequent of the same packet. So in order to avoid that, the anti-replay plays a role. Next, how the IPsec is being formed means it has been formed with the help of IKE. IKE is nothing but an internet key exchange. It is the method of exchanging keys for encryption and authentication over an unsecured network as the internet through a secured manner. That's what IKE plays. IKE is being established based on the two methods as Phase 1 and Phase 2. What we call as IKE Phase 1 and IKE Phase 2. IKE Phase 1 is also called to be as the ISAKMP, which is Internet Security Association and Key Management Protocol. In IKE Phase 1, there is a negotiation occurs between the two peers based on the keys. First, it will authenticate. The key is being exchanged between them. Based on the keys, it will authenticate to whom you are speaking, and there are certain hashing algorithms will be processed to make sure to concerned person we are speaking in a secured manner. That's what is the IKE Phase 1 deals about. While in case of IKE Phase 2, the data will be transmitted. Within the Phase 1, the Phase 2 will be there and the data will be transmitted between them. Let's discuss about IKE Phase 2 in the next session. This session is all about IKE Phase 1. To give you a more detail about IKE Phase 1, you can just look into this diagram over here. This is how tunnel looks like. First, initially, the IKE Phase 1 will be formed. The IKE Phase 1, within the IKE Phase 1, the IKE Phase 2 will be there. If IKE Phase 1 is not formed, the IKE Phase 2 will never come up. Based on the IKE Phase 1, IKE Phase 1, it just checks about authentication between the two peers. That is, to the concerned person we are speaking, it just forms about to which person we are speaking is right, and to the concerned person, the packet is being encrypted in the correct manner. This is all the information that we will negotiate and make sure you can transmit that packet. That's what IKE Phase 1 is about. Once IKE Phase 1 is successful, then it move on to the IKE Phase 2 for data transmission between the two ends. This is something like you are using a mobile phone and you just have a key or a password for the mobile phone, and this is a IKE Phase 1, the mobile phone password. While in case of IKE Phase 2 is like that, you are keeping a password for each apps that you have installed, as WhatsApp, Facebook, Messenger, whatever be, you are just keeping a password for that. So in order to open a phone, you use one password, and while for accessing the interior apps, there's another password for that. So in the same way, the IKE Phase 1 is like the mobile password, and IKE Phase 2 is like the application password, which helps you to protect the data. This is what about IKE Phase 1 and IKE Phase 2. Let's get into the configuration part. This is the basic configuration part of ISAKMP, that is IKE Phase 1. First, we look into the authentication. Authentication here is a pre-share. That is a key that is to be exchanged between the two ends to make sure to whom we are speaking is the right person. So the key should have to be the same at both the ends, and the peer IP should have to match at the end to whom we are speaking. Once it is make sure that's the right person we are speaking, then the authentication process gets completed. Next, move on to the encryption. What it does? Encryption algorithm that we are using is AES, 3DES or DES. AES is more considered to be as a most secured as compared to that of a DES and 3DES. It's just an algorithm to run an encryption, and encryption is totally based on the keys in IKE Phase 1. Keys are one that helps to encrypt the data. Encryption and decryption is totally based on the keys. There are two types of keys. They are said to be as a symmetric and asymmetric keys. And symmetric keys means we use the same key between the two ends, that is between the peer ends, to encrypt and at the same time to decrypt the data. One of the drawbacks between the symmetric keys is that the key should be shared to all the peers, that is to all the end-to-end connections, to make sure they know the correct key for encrypting and decrypting the data. If they have changed the key or something, they couldn't be able to encrypt or decrypt the data. That's one major disadvantage for symmetric keys. And suppose if a third-party hacker or a third-party person who just tries to capture the packet, and if he try to decrypt the packet, if he just gets the key, if he comes to know about a key, he can encrypt and decrypt whatever the information he can do then the symmetric keys. So that's also a major drawback of symmetric keys. While in case of asymmetric keys can also do encryption and decryption, but a little bit different manner. How does it do? Means it will just generate two keys as private and public key. To make it very simpler, what asymmetric keys means, it does encryption in one key and decryption in other key at both the peer ends. DH group only does this type of encryption. DH group will generate two keys as private and public key on each peer. To make it more simpler, let's look into this diagram. Let's consider the connection is between the server and the spoke 1. So the server will have a public and a private key, and a spoke 1 will also have a public and a private key. Each public and private keys will be different on both the routers. So what they do is they just share the public key between the ends. That is, the spoke 1 will share its public key to server, and server will share the public key to spoke 1. So server and spoke will share their public key, but a private key will not be shared between the two ends. So if spoke 1 needs to send information or send a traffic to server, from spoke 1 to server, if it needs to send a traffic, so what spoke 1 does is that it will just encrypt the data with the help of the public key that is it gets from the server end. So it will just send the traffic with this public key, that is the server's public key, whichever the key it is having. With that public key, it will encrypt the data and send it to the server. So if a server gets this, once the server gets this information, it needs to decrypt the information. So for decrypting, it needs to use its private key. The public key will not be used. For decryption, it's a private key, and the private key will not be shared to anyone. So it plays a vital role in terms of security. If a spoke 1 gets the same information that it sends to this end, with the public key. That is the information that it has got from the server end. The same information, if a spoke 1 gets it and tries to decrypt with the spoke 1's private key, it will not be decrypted. So each spoke on the server has a unique public and private key. To whomsoever person we are sending, that person can only decrypt the information. So in this manner, it plays a vital role in terms of security. So this is what all about we have discussed now. Each peer will have its own public and private keys. Public key will be shared between the each peers, and a private key will not be shared. Each private and public key will be unique, and our neighbor public key will be used for encrypting the traffic. Our own public key will be used for decrypt the traffic. The strength of the keys, that is encryption, is totally based on the DH groups, that is group 1, group 2 or group 5. So group 1 belongs to 768 bits and 1024 for group 2 and 2048 for group 5. So higher the group number, it will be very more complex, that is more secured in terms of encryption and decryption. And finally comes to an essay. Essay is nothing but it is a collection of information. It is a collection of all the information as encryption, authentication, and what's all the key that we are using. All the information is being combined into a single block called as a essay, security association. Once the essay is up, only the IPsec, that is the phase 1, will get up. So this is about essay. Essay is nothing but it is a combination of all the information that we have given on a particular phase. That's what a essay is about. That's it. This is about IPsec essay. Sorry, IKE phase 1 essay. In the next video, we just look about IKE phase 2. Thanks for watching. Until next time.